welcome to lecture 3.5, slope of a line. So what the slope of a line means is that it measures how steep the line is. So generally, if the line is more straight up and down, it is steeper than if it's lying flat. So the more that we twist our line to where it's almost all the way vertical, the more steep it is. Now we can also figure out if our slope is negative or positive by the way that the line is heading. In essence, if I'm a person and I run into this first line and I literally stand on top of the line and I start walking, and I start from the left and I go to the right, am I going downward or upward? If I'm going downward, almost like I'm walking down a mountain, then it is a negative slope. If I'm going upward or uphill, it is going to be a positive slope. The other two options we have is flat. If it's the floor, if it's flat, I have zero slope. And the other is, if it is a vertical line, I'm straight up and down, I'm a wall, and you don't want walls to tilt one way or the other, it has no slope, not zero slope. Zero slope is a horizontal line, whereas a vertical line is no slope. So how do we figure out what the slope of a line is? Well, the slope is going to be the vertical change over the horizontal change. So let's pretend we have a line and we have a generic point 1 and a generic point 2. And so my point 1 is going to be at x1, y1. Now, granted, I don't know what values they are, but I can use x1, y1 to signify where point 1 is. And then point 2, again, I'm going to say it's x2, y2. So that's the point location. So if my slope is my vertical change over my horizontal change, you may have also heard it called rise over run. So rise meaning how much I go up and down, the rise, over the run, how much I go left and right. So how do we figure out what the run is and what the rise is? Or, in essence, what is the horizontal change and what is the vertical change? Well, the horizontal change is the point where I left off, which is x2, minus x1 would give me the distance. For example, what if x1 was 3 and x2 is 5? Well, how long is the distance? 5 minus 2. What if my x1 was negative 1 and my x2 was 3? Well, the difference is going to be 3 minus negative 1, which in essence is 3 plus 1, so we know our distance is 4. Thinking the same way between y1 and y2, the difference between y2 and y1 is going to give me how much I changed. So think about that. How much change? x2 minus x1 will give me the change in horizontal change. And my y2 minus y1 will give me the difference in my vertical change. Okay? That's just this distance here. Well, if y1 was at 2 and y2 is at 8, how many more did I go up? Oh, 8 minus 2 is 6. So the change is 6. So let's look at the formal definition of slope. If 2 points, x1 and y1, and x2 and y2 are any two different points, then the slope of the line on which they lie is, our slope equals m, that's our special name for slope, m, is the rise over the run. In other words, vertical change versus horizontal change over horizontal change. That would give us y2 minus y1 all over x2 minus x1. Let's see an example. Let's find the slope of the line between the points 1, 2 and 3, 5. So if we think about it, here's our x2, y2, pardon me, and x1, y1. We're going to use the 2 points to put into our formula where m is y2 minus y1, so 5 minus 2, all over x2 minus x1. x2 is 3, x1 is 1, so 5 minus 2 is 3, and 3 minus 1 is 2. Okay. So now I have my 2 points, and again my run, the way that I'm moving left and right, my run is 2, and my rise is 3. Now you might be asking, how do I know if I move left or right, and how do I know I move up or down? Well, it depends on the sign of the slope. Your denominator, generally, is always written as a positive number, so you're always going to move to the right. Your numerator can be either positive or negative. If it is positive, we move up. If it's negative, we move down. Now, because we generally write fractions with the negative for the numerator, we're usually determining if we're going up or down versus we always go right. But if you give the negative to the bottom number, then you can move left, because it would be a negative 2. Left 2. But then the top number would be positive, so you'd move up 3. We'll see more examples, so that will start making a little bit more sense. So let's see graphically what that looks like. Again, 3 over 2, my 2 points, I move over to the right 2, and since it's a positive 3, I move up 3. Okay, let's try an example. Given 2 points, I need to find the slope of the line, and then I want to plot it. So again, my slope is going to be m equals y2 minus y1 all over x2 minus x1. I'm going to treat the second point as my x2, y2, and the first point as x1, y1. So y2 is going to be negative 4 minus y1 is 1 all over x2 is 5 minus x2 minus x1, where x1 is negative 2. Gives me negative 4 minus 1, negative 5, and 5 minus a negative 2 becomes 5 plus 2, giving me 7. So my slope is negative 5/7. I'm going to choose one of the points. Just for ease, I'll go ahead and take the first point of negative 2, 1. And from this first point of negative 2, 1, I'm going to use my slope to plot my next point. So my next, I'm going to move 7 to the right from the point that I start. 7 to the right. 1, 2, 3, 4, 5, 6, 7. And then move down 5. 1, 2, 3, 4, 5. And I'm way down here at 5, negative 4. So 5, negative 4. Right, that's turns out 5, negative 4. I'm going to connect my dots for my line. And I've plotted the line just using the slope that I found, as well as the 1 point and using the slope to find my second point. Now in this example, we're going to graph a line with the slope of 3 halves and the y-intercept of 1. So I don't have to find out what my slope is. They give me my slope and they give me the y-intercept. Now remember, the y-intercept is when x equals 0. So when x equals 0, y will equal 1. And now, from that point, I'm going to move 2 to the right and 3 up, giving me 2, 4. And now that I have my 2 points, connect my points. And I just want to make sure that I'm labeling my graph. And this one was 2, 4. Let's take a look at 3 different types of graphs that are very special, and the equations you should start to recognize. So a line that goes through the origin looks like y equals mx, where the slope equals m, the x-intercept equals 0, and the y-intercept equals 0, because it goes through the origin. A vertical line is the equation where x equals a. It has no slope. It's a wall. It has no slope. It's not tilting one way or the other. It has no slope. Not 0 slope, but no slope. The x-intercept is a, and the y-intercept is none, unless the vertical line is sitting right on top of the y-axis, and then if it is, x equals 0, and the y-intercept is the y-axis. It's everything. A horizontal line is where the equation looked like y equals b. The slope is 0. It is a flat line. It is 0. The x-intercept is none, and the y-intercept is b. But again, if this line, if this horizontal line is on top of the x-axis, so y equals 0, then the x-intercept is the x-axis. So that's it for this lecture. So until next time, be seeing you.